Thank you everybody for joining us today. This is a webinar session by the Committee on Earth Observation Satellites. And we are joined here today by Dr. Robert Woodcock, where he'll be presenting on the future data access and analysis architectures. Dr. Woodcock is the CIOS Working Groups on Earth Information Systems and Services Vice Chair. And if you have any questions throughout this presentation, please feel free to type them into the questions box as you think of them, but we will address those questions as best as we can at the conclusion of Robert's presentation. So with that, I will pass this off to Robert. Thank you.
Hello, everybody. Thank you for attending the webinar today and for finding out more about the future data access and analysis architectures activities within CIOS. So by way of introduction, this initiative started back in 2017, so it's been a couple of short years in which the Committee on Earth Observation Satellites, which is made up of the major space agencies across the globe, and they started looking at what was happening with Earth observation data globally and how we as space agencies can help the users of our Earth observation data that is collected be better able to utilize it. And there were a number of trends that were apparent during that time. First of all, we were expecting some fairly heavy increases in the digital economy, particularly related to the ability to do cloud computing and the kinds of business models that that supports for industry and research purposes and for government. We were also apparent was just the growing awareness around Earth observation data and how useful it can be to use satellite data in a very wide range of application areas beyond the scientific ones, which much of this data was originally collected for, including out to things like insurance and agriculture and so forth. And the other thing that was quite apparent was the increasing number of global services and partnerships that exist for things like the United Nations Sustainable Development Goals, helping to improve our environment, but also into just the straight up cooperation between countries on things like climate change and how to support that effectively. So CIOS provides, through its various satellite missions, a lot of open data, and our goal is to make that open data available in an interoperable form that's easy to discover and, more importantly, easy to use. Now, with this change, we saw that the substantial growth in the Earth observation economy was really going to be driven a lot by cloud computing and the new ability to have different kinds of analytics platforms that we couldn't do previously. The ability to host data in the cloud at a global scale for all the time that satellites have been created and collecting data is really quite astonishing. The opportunities that exist to be able to just spin up, even for a short period of time, some global data analysis was becoming increasingly accessible to more and more people through the use of cloud computing, because you just buy what you need for the application that you're running rather than having to set up your own data center. The other thing that's apparent is we needed to work on things like the tools that people use to write their applications, whether it be a web browser application or a GIS package or a specific scientific tool, or even an insurance dashboard where somebody's using Earth observation data to feed into some sort of insurance assessment. Those types of development interfaces need to be considered when we're looking at how the CIOS data is made available to others. We also saw a shift away from people wanting to deal with lots of files and downloading files of Earth observation data to one where they're actually dealing with DataCubes of data, both time and space and sensor observation type, and using that easily together. So there was a lot of work to be done looking at how data is actually discovered and made available for analytical purposes. At the same time as all this was occurring around the technology science for the platforms, CSIRO itself was launching through its agencies a wide variety of new satellite capabilities. These satellites collect data more frequently. Some now collecting like every 6 minutes pictures of half the planet, which is a little frightening amount of data. The data needs under those circumstances not just be accessible, but ready to analyze if you want to get a very timely response, particularly in disaster management type environments. And with the wide variety of sensors that are going up, people are looking to combine things like optical data with radar data to get the best of both worlds from those different sensors. So all this was happening at the same time. And whilst it's certainly a significant change and a significant opportunity, there are some significant challenges that kick into play for those of us that are trying to develop applications and make use of this data. And that's where the whole area of future data architectures was born. It was born as a conversation between CSIRO agencies to discuss how we could better make our information available from the different agencies. They are different agencies, but in a consistent way that people could very readily access and, importantly, analyze on their chosen computing platform. Sorry, I've just noticed we're having a little trouble with audio. Somebody's just mentioned. Is it going okay now? All right, I'll just keep going. I assume it's okay. It looks like it's fine from my end. All right. So a colleague of mine asked me the question the other day, FDA, Future Data Access and Analysis Architectures, what's in it for me? Can you show me a picture? Okay, that confirmed the audio is fine now. So, okay, hopefully nobody else is having any trouble. All right, so this is actually quite tricky. A lot of what's happening with future data analysis and access architectures, I'll just call it FDA from now on, is actually under the hood. It's not really visible through the average Earth observation portal, although as a user, you'll feel its impact. And so we have I've got a little table here that's just summarizing some of the things that's happening under the hood, which I'll just bring some of that to your attention. What we found is that the architectural principles are really changing around improving the relationships that exist between the various participants in the Earth observation data analysis pipeline, whether they people that collect data, the people that process and calibrate the data, the people that actually then analyze that data, or the people that publish the results of the analysis. There's a lot more participation that's occurring. So there's a lot richer relationships that exist between the organizations involved, as well as between the data sets that are being used. And the example I gave before between using radar data with optical is just one. We're also finding that particularly the use of the cloud is driving a behavior around, I want the information on demand with the analysis, and I want it done my way. So there's a lot more customization and flexibility in the pipelines than might have existed previously in terms of how you access the data. We're also finding that a lot of the data is being duplicated into multiple cloud providers, just as one example. And this leads to the interesting paradox of that there's actually more data available than there ever was before. And at the same time, some of the stuff is actually less accessible and less findable because there are so many duplicates. And it's not entirely clear which one you should use under what circumstances. So the way we've been looking at this is these headings: interaction, integration, interoperability, interfaces, trying to look at what the changes has occurred and effectively empowering a lot more people to be able to perform their analysis in their way. So I've already mentioned that we've moved from discovery and download of files to really in-place analysis of ready-to-use data. So the data needs to be in a form that's ready for analysis. We refer to that as analysis-ready data, and there's a whole stream of work on that in CSIRO. And we need the ability to make that data that is in certain cloud providers and so forth discoverable alongside the compute that people might choose to use, because some people might choose one cloud provider over another cloud provider for whatever reason, and then combine that into actually an application. So this all needs to happen on demand, and that puts pressure on discoverability and that interaction process. I've mentioned before several times now the integration of multiple sensors. We've really gone from an area where looking for a single sensor has been the go to an area where we actually want several sensors simultaneously. This leads to an interesting phenomena. If you're using multiple providers of, say, optical data, how do you actually get those to be calibrated so that the observations made, if they were detecting the same wavelength of light, can those observations be compared readily? Have they been atmospherically corrected in a suitable way? Have they been terrain corrected? All right, are they actually comparable? And so we need to make sure that those observations themselves are actually able to be compared in that way, or at least you know as a user that they're not, if for some reason they aren't. Interoperability is a well-worn path, making sure that you can actually, use the data from multiple providers. But the emphasis has really shifted from one of being data access and download to your local compute environment to one where you actually use the data in place. So we talk about doing things like moving your algorithms to the data rather than bringing the data download to you. And this is particularly important as the volumes of data have become prohibitively difficult for downloading anyway, even on very high speed networks. And there's a lot of work that's been done on various interfaces to the system. I'm not going to go into those in more detail. You'll see examples of various interfaces of FDA in the pictures that follow. So what are the elements of FDA that we've been working on within CEOS since 2017? Well, we've really moved to a situation where there are practical implementations of some of the things we thought would actually happen. And we're working on improving all of this. It is, however, a little bit of a mess still, as the agencies are all independent, so they work at their own rate. And we have a lot to learn about how to best bring these together to have a great user experience for both application developers and end users. So the themes we've ended up arriving at really fall into these 5 areas. Analysis ready data, which is all about making sure that the data is comparable when used from different sensor types and different satellites, and making sure it's all properly corrected for the atmospheric conditions or terrain conditions that are underway. And that really just saves everybody a lot of flapping around with pre-processing. It's a common need for everyone. There are only a few ways of doing it. And so a lot more users are served if we provide analysis ready data to them. Then there's DataCubes, which is all to do with different ways of processing some very large volumes of data at scale, how you can perform time series drilling through the data, and how you can combine that with a variety of processing environments. Then we have the Earth observation platforms, which is there are quite a wide variety of platforms being built for doing analysis. And they range from websites that you just click on and they just do things through to complete scientific data analysis systems where you're fully customizable. We've also done a lot of work on user metrics and resources inventory. This is really us trying to understand as CEOS how we measure the impact of the improvements that we're making, and that users are actually getting value from the CEOS data, which of course is our goal. And of course, Earth observation data analytics, the whole point of all of this is to enable that analysis to produce new and improved products and outcomes. So I'm just going to highlight through these next few slides some of the changes that we're actually seeing come on stream, and try and bring out what that difference that makes to different types of users. Where possible, I've actually borrowed these imageries and slides from a variety of presentations that were given by the different members of CEOS and GEO for that matter. So I've put in the acknowledgements along the way, and I thank those contributors for their fine work. And so the first one we've got here is this this concept that we're merely moving from this situation where we have pipes of data, where data is accessed collected by a satellite, it's made available by a CS agency in some data center somewhere, and then you download. As a user, you would just download and then you would use that data in place. Under the FDA, we really have a more participatory ecosystem that's co-created. We still have the data owners collecting the data from the satellites and storing it in data centers, but now we're seeing a lot more participation from a much broader group of specialists. One of the most notable one, of course, is the cloud providers, your Googles, your Amazons, and so forth, who are storing vast volumes of this data in their cloud platforms and making it available to the broader community. A lot of that is actually being done through various free programs, but there are also quite a wide variety of paid ones that give you some advantages as well. And of course, their goal here is to have more people using this data on their cloud platforms, producing better results and ultimately earning them a revenue, of course. But then we also have researchers, software vendors providing tools into these platforms, various bits of expertise from other areas coming in. Some of these expertise aren't even Earth observation. Some of the things that I've seen recently are completely different domains, insurance being one of the ones that comes to mind, where the data from Earth observation is combined with other financial and economic data to produce de-risking reports and so forth. So what you're finding is there's a lot more participation compared to the previous work where things moved from satellite through CS agency, through data storage, through download to consumer. Now what we have is this environment where everybody's joining in at various places in here. And in fact, CS itself in its original data providing role has in many respects become a smaller participant. Although of course the data volumes are massive for many of the providers from CS. So all of this sounds very exciting, and it is, and there's a lot of innovation going on. But for a CS agency, this adds some complications. For example, how do you get the data into the cloud in a way that doesn't send you to economic ruin because of the costs of putting 100 petabytes of data in somebody's cloud, let alone doing it in more than one cloud? And there's all sorts of little business model and economic issues, as well as the technical architecture parts that kick into play. And so whilst this looks like one little slide here with an arrow that says data for a CS agency, in practice, it actually looks more like this. And this is a slide courtesy of WGISS about the changes they've been making on their Landsat processing pipeline. I'm not going to go into this slide in detail. I really just put it here to give you some idea that underneath the hood, there's a lot of change, there's a lot of work going on, which is why some of this takes a little bit of time. And there are, of course, multiple CS agencies. This is just one with one satellite. So you can imagine the learning that is going on, the improvements that are being made. But I think it's really important just to notice a couple of things in here. First, some of the more traditional interfaces are still being maintained. People still use them in workflows, so we still need to keep things like Earth Explorer up and running. But now we've got some additional APIs that deal with areas of interest rather than just files coming down and getting scenes. You can actually select specific regions and just get that time and space. We have initiatives like the Open DataCube that are actually having direct access to the cloud-based scenes. The clouds themselves are being, the scenes and data themselves are being stored in the cloud directly for use. You don't need to download. And in fact, if you run your processing in the same data center, in the same cloud that this is running in, which is entirely possible, then you don't actually have to download any data at all. You just use it in place with, it's in quite a large data center, so you can use it with quite a lot of compute if you choose to do so. So there's some important things going on in this space. One of the things that's actually apparent, not readily apparent on here, is a lot of the collection processing that USGS does to get its data up to analysis ready data form is now also being done in the cloud, which is affording them some new opportunities in how they can improve and iterate on that processing and the quality of the collection over time. So what does it actually look like? We're going to pick a couple of examples just to touch on a few highlights around the architectural change. And there are many participants and there are many views that are going on. It is messy. So WGISS through CSIRO is working with a range of groups across CSIRO. We're not the only group involved. Land surface imaging, virtual constellation, for example, in CSIRO is working on the analysis ready data standard as we speak. And what we're looking to do is establish a common description of the functional blocks that make up the architecture. We've had a bit of a go at this first go round. We're not happy with the first go, which is why I'm not going to go into this in more detail. But it's an important area for us to try and get right. How we communicate to users, how they can make good use of the CSIRO data, and now the increasing number of analytical capabilities and services that are available for accessing this data. Here's one example that we've looked at, and I want to highlight this one and another one on the next slide, just to illustrate that we are starting to see some convergence in the architecture. So this slide's from the CSIRO Open DataCube team, part of the CSIRO Systems Engineering Office. This project starts at the stage where we've actually got analysis ready data, so the work of, say, WGISS and the European Space Agency bring in and create the analysis ready data, which is available in the cloud. And then the Open DataCube infrastructure provides the API for actually performing computation, organizing that data and doing analysis. And they publish a range of applications and tools as part of an application library that runs on this DataCube infrastructure. So this it's pretty straightforward in this diagram. There's the three layers that exist for your data, your analytical capability in the middle here, and then the various applications and visualization tools that do exist. If you look at the European equivalent, the PGS DataCube, you see a similar thing. Their data layer here, of course, ESA is a data providing satellite launching agency, so they have a lot of control over their data and where it is. So they have, when it says data layer here, think hundreds of petabytes because it is massive. Then they have their data analytics service. Their particular service actually works through an Open Geospatial Consortium web coverage service interoperability API over the web. And they highlight the fact that it's pixel-based for access. And then there's a variety of tools available for using the system. And the two I'd like to highlight here that are a little bit different to what we've seen in the past. We've done a lot of web-based work in the past through CSIRO, but now we're seeing a lot more of these Jupyter notebooks, which are web-based analytics environments, where you can actually get in there and you can cut some code and you can have quite an interactive experience, but you don't have to necessarily be a full programmer to be able to do this. And the notebooks themselves contain documentation and code. So quite a lot of the applications are published using these Jupyter notebooks, so you can work through them and then you can tailor them to your particular needs. And then, of course, we've got the kind of APIs that you see for programmers to use at the command line and so forth. And all of these make use of the same underlying infrastructure. And what you find if you take a close look at these is I've turned the Open DataCube on its side over here. And you can see that the layering actually is very similar for each of these. The Open DataCube, in fact, has all three of these APIs at the top, although this particular slide didn't show that. The Open DataCube doesn't use an OGC interface here. It has a different API. So whilst these layers are equivalent, they're not currently directly interoperable. And it's kind of curious to wonder is that a big problem or not as a CSIRO agency? It's one of our open questions that we're wrestling with at the moment is what does it mean to be interoperable in this new world? And we'll touch more on that in a little bit. And of course, the data is coming through. Interesting to note, one of the differences here is that the Open DataCube does start with the analysis ready data. It assumes that the CSIRO Space Agency has provided analysis ready data in an accessible form. Whereas in ESA's case, they do that, but they also control these missions, so they could actually just work directly off their native data if they chose to. So there's a lot of equivalence going on here, and we're starting to see this convergence occur across a number of areas in the Future Data Access and Analysis Architectures Initiative. And as those independent agencies start to converge on this, we should start to see some clearer documentation and clearer design on how to use the services that CIOS are making available. From an access point of view, we seem to be getting quite a lot of OGC services coming out of the various agencies' FDA initiatives. I've just got one here from Sentinel Hub. They're working with the European Space Agency to make the Sentinel series of data available. And as you can see, they've got a range of OGC service standards available, plus their own API. And what we're finding is that particularly when you're doing the analytics, there's some of the OGC services don't quite get you there, and you need a slightly different way of approaching when you're using things like R as a programming language or Python and so forth. And so you have these web-based APIs. And of course, these web-based APIs belong and are developed by individual agencies. So again, on the analytics side, the interoperability is not as strong. On the access side, the OGC standards are holding up very well in the new world. And so we're seeing some of that going on at the moment, where we're looking for some more convergence around the analytics API if we can achieve it in a reasonable way. And of course, I'll just also highlight again the importance of analysis ready data, or ARD, the ability to have, when you've got multiple optical satellites, in this case, Sentinel-2 and Landsat, or multiple SAR satellites, all collecting very similar data, making sure that those measurements can be used together because they've all been calibrated in a similar form. The other way in which data is accessed that's a little different is directly in S3 buckets. And I've just got up here the Registry of Open Data on AWS as an example. And I wanted to highlight one of the challenges we have in FDA when it comes to having data in the cloud. And I'm going to just use the AWS example, but this example applies equally well to data holdings on other providers, whether they be Google or the DSs in Europe and so forth. This is from, these screenshots are subsets of the pages from the published online by AWS describing these collections. And I've picked Landsat 8 and Sentinel-2 because these are both optical satellites. They have slightly different orbits and frequency of collection. So they're very good to use together if you want to have to at the same patch of ground and get a very deep temporal time series. And this is great because these are in S3 buckets. These are both stored on Amazon in an S3 bucket, and they're readily available to you. Now, that's great. I can get my Open DataCube code. I use the Open DataCube for my analysis myself. I can index this data in place in the bucket. I can perform the analysis. I don't have to download any information at all to any of my computers. I can just put my compute in the same data center, literally send my algorithms to the data center and have them run. And that means I've got global access to data that I'm not having to store myself. This is a great opportunity, but you have to be a little bit careful at the moment. So if you look at this, you'll see that the Sentinel-2 data is held in the EU Central 1 region, and the Landsat 8 data is held in the US West 2 region. If I naively access both of those buckets from either of those regions or one of those regions, what will happen is I will end up transferring data within the same cloud, but between regions. And this can attract a fairly substantial cost if you accidentally download half a planet's worth of data for 10 years into the other region. And this isn't always obvious. The S3 bucket names are global. So you do have to pay attention to the fact that these are different regions. The way in which I do my processing is I do my Landsat processing in that region, the US West. I do my Sentinel-2 processing in the EU Central 1. And then the result, which is usually considerably smaller amount of information, I transfer to wherever I want to use it in the end, which might be one of those two regions. But that saves me having to process and move all of the data, and it removes those costs. The other thing to watch for when you've got data in these S3 buckets, which as I say is a very good thing to have, is for things like this. So this one's a request to pays bucket. So when you access this bucket, there will be some costs associated with the access on it that will be met by you and your AWS account, as opposed to on the other one where it doesn't say that. Presumably that is not request to pays, and it'll actually be met by the people that are publishing that data, which in that case is Planet. So this is an interesting phenomena that you need to watch out for when using some of these buckets. And I think part of the goal for CIOS agencies is to make this type of information very easily accessible. And that way, when you go to do your computation, you can design your code to use the most appropriate location for your computation with the most amount of data, and be very aware of where these back-end costs might pop up on you. So this data in the cloud is a very good area. It's a great thing. It gives us access to global archives without having to manage and download all the data. There's just a few little things you've got to watch out for as you go. And I think CIOS, working with WGISS, we're going to be looking at ways to try and make that more explicit so you can very easily see it. I'll also note that whilst Sentinel-2 is a European satellite and Landsat 8 is a USGS satellite, these data sets are managed by two different organizations, and neither of them are the European Space Agency and USGS. This is what I mean by there being duplicates and replicas. So one of the other things you'll need to know as a user is this Sentinel-2 data identical to the stuff that you would get from the European Space Agency? And that ability to understand where data's come from, has it been modified, is again something I think we need to bake into the FDA ecosystem. On an analytics viewpoint, I'll just touch on this briefly, but analytics is really the whole idea here is to get around to on-the-fly data access and interactive analysis. I've got an example on the screen there from the CSIRO, my home organization, and our Earth Analytics Science and Innovation Hub, which runs in the cloud and has access to a lot of the data that's up in the cloud. It's a fully interactive Jupyter Notebook environment. A lot of the other FDA initiatives through Europe and the US are both running these types of analytical capabilities, and indeed using Jupyter Hubs and using DataCubes, a variety of them. There's the Open DataCube that CIOS itself is working with, but there's also some others that are being developed by various independent groups, and they're all very, very similar. Not quite the same, but very similar in terms of their approach. Interestingly enough, the types of libraries that are being used underneath generally fall in. Python is very heavily used, as is the X-array data model. So those are things to check out if you haven't looked into them and you're really wanting to work with Earth observation data. There's a lot of work going on with Python and X-array in particular, and of course R being the next most popular tool getting used in that analytics space. We do have to be a little bit careful with some of this FDA stuff. Some of the choices might actually matter a lot. In particular, when we're doing direct data access, interoperability has been important. For a lot of cases, the use of analysis-ready data for the observations, but also just the file format. If the data is in the cloud at the end of an S3 or HTTP link, having a GTIF makes a lot of sense because people can use it. The trouble is that a GTIF in a cloud environment isn't the best format for performance of actual cloud-based analytics. And this is because clouds use object storage. They don't use file systems in the traditional sense. So a lot of the libraries and the performance tends to fall through the floor and be very bad when you naively use a straight standard file format in these environments. And this becomes particularly important if you're doing direct compute access, where the files in their native form are being used as part of the analysis and you're no longer downloading them. And so that there's a bit of a trade-off that occurs around achieving interoperability in the sense that we've traditionally made it, and achieving analytical performance at scale, particularly at the global scale. So we've started looking in various agencies at cloud compute ready data. And there are at least three that are being bandied around quite a lot at the moment. One is COGS, Cloud Optimized GTIFs. These are GTIFs that internally are tiled and formatted a little bit better to support parallel access as required by cloud environments to achieve high performance on their types of object storage. Another is NetCDF in the cloud, and another is Zarr, which is cloud native array storage. Now, those last two have something in common. So I just pulled out a slide from the talk that was given recently to me on the S3 NetCDF 4 format. Effectively, what the difference is here is rather than having a single file, which you would access by actually pulling the entire file into a local cache and using it, what happens is you actually split that file up, and where you used to have chunking within a file, you now store the individual chunks on object storage individually. Now, what that enables is it means that as you increase the number of compute nodes in the cloud, and let's face it, you could literally have 1 million cores in the cloud if you chose to, you create a parallel access to that independent subarray. And on these types of HTTP-based APIs, like S3 uses HTTP, that kind of parallelism to get smaller chunks of independent objects is actually very important. So a lot of work done on Zarr. CSIRO had its own S3 array IO format, HDF in the cloud, and so forth. Are all very similar in that they actually take what would normally have been a single file with chunking inside of it and split out those chunks into independent objects in the storage system. And it's all about enabling this parallelization to occur. And on the cloud, this parallelization scales extraordinarily. The cross-sectional bandwidth that's available as you increase the number of compute nodes is truly extraordinary in terms of the transfer rates. In fact, you're better off using smaller compute nodes and a lot more of them in order to increase this if you're IO bound. So this is an important aspect. The downside of this approach is this is no longer a NetCDF file. This is no longer a GeoTIFF, which means you can't simply go and download the file anymore. And so your interoperability suffers when you do this. But of course, interoperability is all about having tools that can read and deal with this thing. So the more tools learn how to do this, the less the interoperability will be a problem down the track. But right now, that's a little bit of a trade-off, and it's something we've got to be aware of. So on the discovery side, we now have more than just data to sorry, my headset decided to turn itself off for some reason. So what we have now is a need to find more than data. We have analytical services. We have a variety of tools that people need to use. We have a lot of algorithms that are being published and notebooks for Jupyter that are being published independently. We have the CalVal, calibration and validation issues to ensure that your data is in fact comparable across this now wide variety of sources. And of course, the locality of the data, which data center is it in? Will I get hit with network costs transferring data? There are replicas of data in different cloud providers. Are they in fact the same? All of these types of issues kick into play. So in WGISS, we've been providing for some time for CIS, the International Directory Network, to help discover data. And what we've been doing recently is inventorying the other artifacts that we actually need to be tracking and providing information on. And our objective is to improve our discovery system so that you can actually easily come into there and find all the services that will work with certain pieces of data, or find all the replicas of CIOS source data that are actually identical that are held in the cloud providers. Now, it's going to be an interesting exercise because there's a lot of third parties involved in that now broader community. But this is what we're working on to try and make this it easier to use this much richer co-developed ecosystem. So it's a bit of a watch this space one. I believe the services is expected to come up in the next 6 months or so into the IDN. Yeah, still a lot to learn about how to help users really access this now vast a wealth of information that's coming through. And this is just the CIOS agencies. There's other groups as well, of course. So really that's CSIRO FDA in a bit of a high-level nutshell. There's a lot of new opportunities and new applications, really streamlined data use, analytics at global scales, and just improving that participation is what this is all about for all of you, ultimately. Now I realize this was a little dry. It is a discussion about architecture as opposed to applications, but we will be holding a future FDA follow-up to this session and asking some of the CIOS agencies to actually demonstrate their various environments and services for you in a future webinar. So that'll be coming up. I don't actually have the date yet. I don't know when that will be, but it should be in the next couple of months. We'll start to see that come on stream. But I think for now, that's it from me, and I will hand it over to Brock to assist in handling any questions that are coming through. Thank you.
Thank you very much, Robert. So yeah, please, if you have any questions for Robert on this subject or the future directions of this, please type your questions into the questions area, and we'll read those aloud and let Robert respond, and we'll try to get to as many as we can. So I'm going to let a few roll in here, and then we'll get right to them. Actually, Robert, I can get things started off here. I just have a quick question for you here too. So you said there's a follow-up webinar coming up with some demonstrations. Can you tell me a little bit more about that? And then also on top of that, are there any capacity building events in the coming years, workshops, in-person, things like this along these same lines?
Certainly. So at the last WGISS meeting, which will be nearly 6 months ago now, we actually asked a wide variety of CIOS agencies to demonstrate their various elements of FDA. Some of them were full application development environments where they had some themes of disaster recovery and the tool sets they were using. Others were things around pipelines for producing analysis ready data and what that actually meant, and other ones were things like how to just access the buckets in the cloud in an efficient way to perform analysis and so forth. So we had this quite a large range of various FDA initiatives that were being conducted by the agencies. For WGISS, this was an opportunity for us to see how to combine those APIs and bring them together. But we felt that it would be good to bring those to the fore, to give an introduction to FDA, which we've done today, and then to actually show some of those examples as live demonstrations. So it's going to take a little bit of time to prepare for that, obviously. But we're hoping that in the next couple of months, we'll see that in a webinar where you'll actually see some more hands-on demonstrations of some of this technology and the impacts that it can have for users. And the other part of your question is to do with the capability of development. I think there's quite a lot of work to do there. So the working group on capacity building within CEOS does provide things and support things like this webinar approach. But also there are a variety of workshops that are held. The Open DataCube community runs a number of them. There'll be some at the GEO meeting coming up towards the end of the year. The GEO Ministerial has some site events that will contain workshops, all of which are using various FDA elements and data from CEOS agencies. So there's quite a lot of work going on there, done by individual agencies as well as coordinated through CEOS. And I believe there's a timeline for some of those on the CEOS website under the WGISS, under the Working Group for Capacity Development, WGCapD, that you can take a look at.
Oh, wonderful. Wonderful. Yeah. Could you actually type into the chat the when you have a chance the URL to that website so people can find out more information?
I'll have to find it myself. Off the top of my head, I don't actually know it.
I thought you might have it bookmarked or something, but yeah.
Give me a moment. I will see if I can find it.
Now, you mentioned a GEO meeting that you're going to be present at. Are there any other conferences or meetings that you and your working group regularly attend or present at?
Well, the CEOS agencies are active in most of the Earth observation conferences that happen globally. So you'll find a variety of us at those. The major ones for CEOS itself meetings, so and they're open to CEOS agencies primarily, and of course GEO has its, but it's a very long list. In fact, the website that I just typed in with working groups WGCapD has a list of meetings that CEOS itself holds, but you'll generally find at the major Earth observation conferences you'll have people like me and other members of CEOS presenting on a variety of topics related to the data analysis. And these days, a lot of that will be using the FDA type elements and cloud computing and so forth that we've been talking about today.
Great, yeah, and I see that the URL is in the chat. So if anybody wants to read up a little bit more about some of the upcoming events, there you go. If anybody has any questions, feel free to type them into the questions box. We'll give you a couple more minutes to do so. If not, Robert, I don't quite know if your contact information, if you wanted to share that. We have like a few people on here, and we can, if anybody has any questions to follow up, and we're going to make this recording available in just a little bit of time here. Actually, I do see a question that came in. Ben writes, are there any plans to mirror data sets between S3 regions to mitigate issues of cost transferring between regions and allow for centralized analysis? This is from Ben Lighton.
Yeah, so that's a very interesting question and a very good one. This really comes down to business models for the various people that are actually publishing data out there. So as you can imagine, replicating some of these data sets across multiple data centers would be horrendously expensive for the CEOS agency. So it's unlikely that a CEOS agency itself might do that, although some are. And some of the larger ones are actually doing it by replicating each other's data, which is quite cool. And this is because things like using USGS data with European Space Agency data makes good sense. So, so quite often you'll find that one of the agencies has duplicated the other agency's data into their chosen region. So I know, for example, that you can actually get co-located Sentinel and USGS Landsat data in a single region. So that is happening. The other thing, of course, is that the way in which the cloud providers themselves are using this data, they want to generate more activity and more use of the cloud because that's where they make their money from. So some of the large data providers are actually duplicating the data themselves, or what they're doing is making it so that there are no egress costs, which is the cost of moving between the data centers. So there might be it might be slightly slower to access the data, but you won't get charged for it. And a lot of the time it's the charging for it part that's confusing for people. So that is a bit of a moving feast, and it really does depend on how the business model evolves, and that'll be related to how people are using the data. So I think really the more people using the data by the cloud providers, the more likely that data is to become accessible from more regions, which will be quite important. And of course, tracking and dealing with the replicas is another thing that if we can help with that through CIOS, that can help you to find that duplicate a little bit more readily. So, but certainly the CIOS agencies themselves are generally just making their data available from one region at this stage.
Great, thank you. Anybody else have any questions? Please feel free to type them into the questions area. If not, we'll give it a couple minutes and then we can close it down here.
Actually, I might just extend Ben's question a little bit.
Please go for
it. Just while others are typing up their questions, if they have any. One of the interesting questions with that one, you mentioned, Ben, there the S3 regions that assumes that everything's in Amazon because S3 is an Amazon technology. It's interesting to note that if you start going across clouds, this question gets even more difficult. So I wanted to use some data from a commercial provider that's very high resolution with some of the open data, moderate resolution data available from both USGS and Europe. And I found myself with a situation where I had no choice but to go between Google Cloud and Amazon Cloud because the data wasn't available on both. Now that generates some interesting problems because if you thought you had issues transferring data between regions, you should try doing it between cloud providers. And here we start to see things like the Kubernetes environment. So if you're not familiar with Kubernetes, it's a way of orchestrating services in the cloud. And generally speaking, Kubernetes is used in a single provider, but you can actually federate across providers, which for Earth observation analysis has some interesting opportunities. And I have an experiment underway at the moment, just getting started on doing this with the CSIRO's Earth Analytics Science and Innovation Hub, where when you actually ask for a computation to be done on a data set, it'll move that computation to wherever that data center is on whichever cloud provider it is on as well. So there is a way of moving algorithms to data across not only regions, but providers of that data. So that starts to get to really quite an interesting opportunity there for how to ease the burden of actually finding, accessing, and using this data and not incurring some of these I need to centralize it all costs. In a lot of cases, you don't need to centralize certainly the raw satellite data. So that's an interesting extension, I think, to the issue of moving data around between regions. Is just keep moving the compute, not the data.
So what we're going to do is we're going to email folks who tuned in here today for the follow-up session that's going to happen in the coming months. And we're also going to try to get this recording available as a link through the CS website, possibly in the WGCapD area or a couple different places. So you can pass along with some colleagues who couldn't make it here today or review before the next demonstration webinar. So with that, I'll give some people another chance to write some more questions, but if not, we thank you very much, Robert, for tuning in and giving you this great overview of what's to come.
You're welcome. Certainly trying to help there. I think there's some very exciting times ahead for everyone in this area. So thank you.
Thank you very much.